Warm greetings, friends and dear students. Today we are going to see about the short column and we'll see the load carrying capacity of a short column provided either actual length or the effective length of the column is given. All of you know that the short column is defined as the ratio of the effective length of the column divided by the least radius of gyration, that is equal to L effective divided by R minimum, is less than 12, then it is called as short column. If the slenderness ratio of the column is, that is lambda is less than 12, it is called as a short column. Yeah, short column will fail mainly due to the crushing failure. So if you are able to conduct the test on the short column, it will mainly fail due to the crushing load or the crushing stress. So what will happen if you are applying an axial load? What will happen? The ultimate load can be taken by multiplying the corresponding factor of safety. For example, now we are going to see a simple problem which is of a short column which is of an effective length. L effective is equal to capital L is equal to 2.75 meter, and of cross section, rectangular cross section of the column is 400 mm into 600 mm. It is 400 mm wide and 600 mm deep. What will be the crushing stress in the case of this short column? If you are able to find the lambda value, that will be less than 12, effective length of the column divided by least radius of gyration. So if you are able to find Rx and Ry, which is the lesser value, you have to take as R minimum. So here 400 into 600 rectangular cross section, about which the moment of inertia least value is 600 into 400 millimeter cube divided by 12. So if you are working out, the lambda value would be less than 12, so that is called as a short column. So this short column of a given data will fail mainly due to the crushing load. So finally the crushing stress will be, we have to be able to find. Now what will be the crushing stress for this given problem? The crushing stress, either sigma suffix c or fc, is equal to the given load is then safe axial load. So it is 150 kilonewton, you multiply by the factor of safety of 2. So it is 300 into 10 power 3 Newton divided by area is here 400 into 600. If you are working out the crushing stress, so which will be of nearly around 1.25 megapascal, that is equal to 1.75 Newton per square millimeter. So this crushing stress will be greater than the safe stress. So the column will fail due to the crushing load or the crushing failure. But in the case of long column, that is mainly failed due to the buckling effect, that is the bending effect, that is called as a buckling load or the critical load. So that we have seen in the previous video, especially using the Euler's crippling load, right, for long column. So Euler's crippling load is used only for the long column. We cannot use it for the short column. There is no provision to include this for the short column. That is the derivation only for the Euler's theory for long column only. So if you are able to find, or you can able to apply for both short as well as long column, we have to introduce one more theory which is called as Rankine's theory for column. You can apply Rankine's theory to calculate the failure of long column as well as short column. So it is applicable for both long column and short column. So that is the advantage of the empirical formula, that is called as Rankine's empirical formula, to calculate the critical load either for a short column as well as long column. So this is about the short column Then how we are going to find the crushing stress in the case of short column. So in the next video, we can go and see the Rankine's theory. You can apply it for short column as well as long column, but the Euler's theory is only meant for the long column. The For short column there is no provision is provided in the case of the Euler's theory. So that is the limitation of the Euler's theory for a long column. Thank you very much for patient listening. வாழ்க வையகம் வாழ்க வளமுடன். God bless.